Hello students, so today I'm taking class on the section of solids and we'll continue this chapter a little further with the questions round on the section of solids. And after understanding about each and every concept used in the section of solids, you would be able to definitely understand about the answers, about the drawings that we are going to do in this session. I hope you have gone through the lectures and please ask if you have any queries. Please, I'm also helping you out in this hour of need by making video lectures, so feel free to contact me through this medium YouTube. Comment in the comment box if you are facing any kind of problem in any of the video lectures. Please do let me know, and if any of the other chapters related to the engineering drawing subject, I'll be happy to make another session of the video. Well, this is the question from your assignment, and this is the question number 3. I'll read you the statement. We have a cube which is resting on its base on the horizontal plane, and the cube, you all know that a cube has 1, 2, 3, 4, 5 and 6 square faces. All the faces are in the form of the square, so the shape of the face and the base is similar. So this cube is resting on its base, which is a square on HP, and it's one of its face, the side walls, which is the elevation, and the side walls of the face of the cube, they are inclined to VP at 30 degree. So I've taken this line at an angle 30 degree with the VP and have thus made the projection of the base of the cube from the top view, which will appear as the square, with this edge of the square appears to be at an angle of 30 degree with the vertical plane. In actual, this is the projection, but in actual, this is the face. This side is the face of the cube, which is inclined to VP at 30 degree. Moving on further, once we have the true shape of the base on HP, we'll mark the corners or the vertices of the cube. As this is a solid, so in this type of solid we have one base which is resting on HP, and the second base is at the elevation of the equal to the length which is equal to the side A of the cube. So this is base 1 and there is base 2. So we'll name the bases as per the I have already mentioned in the chapter of solids during the classes, that will name the base 1 with A, B, C, D, and the second base which is actually on HP with 1, 2, 3 and 4. So we'll name base 1 as A, B, C and D. You can start from here also, here also, here also and here also, but we'll go clockwise. So we'll name this corner, which is the projection of the cube in the top view. We'll name this corner as A and then 1, corresponding to the base 2. A for the first base, B for the first base and 2 for the second base. C for the first base and 3 for the second base. D for the first base and 4 for the second base. I'll repeat it again. Base 1 is named as A, B, C and D. Base 2 will be named as 1, 2, 3 and 4. So the points will appear as A1 here, B2 here, C3 here and D4 here. So A, B, C, D corresponds to base 1 and 1, 2, 3, 4 corresponds to the corners of base 2. I'll show you how they look like in the question. In this question, I have marked the points for the base 1 and base 2. It is like what I have said: A1, B2, C3 and D4. So over here I have instructed that base 1, which we are seeing at the first spot, is named as A, B, C, D, A, B, C and D. So I've written A first. Before 1 I have written A, before 2 I have written B, before 3 I have written C, before 4 I have written D. It means we are watching base 1 first and base 2 is lying behind the base 1. So you have named the base 2 with points 1, 2, 3 and 4. As of these notations will be from the top view, so there is no dash or complement sign with the notations. So it is called as A1, B2, C3 and D4 together as A1, together as B2, together as C3 and together as D4. Now if you know that base 1 has 4 corners A, B, C, D, and base 2 has 4 corners 1, 2, 3, 4. So joining the corners together, this corner of base 1 and base 2, if I join them together, these make the face edges of the cube, like here. So A1, B2, C3 and D4, these are the face edges of the cube. Now face edge of the cube will be of what height? Equal to the given length of the side of the cube, and the given length of the side of the cube is given to as 40 mm. So all the sides in this projection, all the sides are 40 mm because this is a cube. The shape of the face and the shape of the base are equal. And over here in the center, I have found the center by joining the diagonals inside a square, and therefore I have got a axis of the cube, and this axis of the cube is named as O1 and O2. So the point O1 is in the center of base 1 and the point O2 is in the center of the base 2. O1 O2 is equal to 40 mm. How come this is 40 mm? Because the height of the cube is also 40 mm, and this is thus called as the axis of the cube. Why it is necessary to make and show the axis of the cube? Because in the question it is given there is a cutting plane and it passes at a certain distance from the axis. So you need to have the axis of the cube, and you need to show the axis of the cube in the projection of this drawing, right? So as when we make the cutting plane line, we have to show it actually at what distance it is passing against the axis of the solid. Now let's see in the next step. What we are going to do is we are going to actually show the cutting plane, but before doing it we will have to project the cube in the front view as well as show the cutting plane. Now if you have gone through the question very carefully, it is written that there is a cutting plane which is parallel to the vertical plane. And can you name a cutting plane which is parallel to the vertical plane? Which is that type of cutting plane? That type of cutting plane is obviously creating a horizontal trace on the horizontal plane, and it will come like this. This will be a line, cutting plane line parallel to the reference line, and it will make a horizontal trace on HP. And this type of cutting plane whose horizontal trace is a line parallel to the reference line, what is this type of cutting plane? If you remember from your previous class, this type of cutting plane is vertical section plane. So cutting plane which is cutting the solid parallel to the vertical plane and creating a horizontal trace in the form of a line parallel to the reference line is a vertical section plane. Now let's see how we can form a cutting line with respect to the line of axis of the solid as per the given statement in the question. If you remember from the question, it was given I have made an angle 30 degree with the vertical face of the cube with the vertical plane, and like you used to do in the projection of solids, after making the top view we used to take the projection lines to the front view to complete the remaining part of the solid. To project the cube in the front view, we will have to take the projections from every corner of the base 1 and base 2 till the XY line, and then from the xy line, including the axis of the solid, we will have to take the height. Now O1 O2 over here in the front view will be 40 mm. So if this is the axis line, we will have to make this axis line with the continuous thin line. So this point is appearing as O1 dash. Now we are using the notations dash in the front view. So this is O1 dash and O2 dash. O1 O2 means this is the axis of the solid, so the notations will become O1 dash and O2 dash. Now I've also taken a cutting plane line here. So this cutting plane line, how it is coming here, cutting plane line, because this is making a horizontal trace on the horizontal plane. So this end is marked as H and this end will be marked as T, and this is the line. Why I have made this line parallel to the reference line? Because it is passing at a distance of 15 mm from the point of axis. We have already mentioned the point of axis in the previous step, that O1 O2 lies in the center of the cube, and the center is found out by using diagonals. So after O1 O2 is found, we have taken a vertical distance of 15 mm away from the O1 O2, and then I have drawn a straight line which is the representation of a cutting plane line in the form of a continuous thick line at the ends, thin elsewhere. This is the line convention that we use, which is parallel to the reference line. Now after making this line, I understand this, that this portion of the solid, this edge which is between the points D4 C3 and this edge which is between A1 and D4, this is being removed by the cutting plane line. This portion is removed by the cutting plane line. If this portion is removed by the cutting plane line, in the yesterday's class, what we did, we made these lines, the portion which is removed, we made these lines with continuous thin lines. Now green color here in the drawing is the dark line and red lines are the light lines. So red lines are the continuous thin lines and green color lines are continuous thick lines. This was the solid. So I'll redraw the edges, this much portion of the solid in the drawing with the use of a red sketch pen. There is a hint to this question. Whenever you're drawing the section of solids, you will always have to start the drawing with a continuous thin line. After understanding all the question, projecting both the views using the section and making the sections and then the hatching lines, you can then make the light lines dark as per your understanding that this is the remaining portion which is left after the cutting of the solid, and this is the light portion which was removed after a cutting plane has passed through this point. Okay, first you will draw all the drawings light with the light pencil in a light not color, in the light pencil, and then you will actually darken those edges and darken those lines after it is all completed. Right, so it's a bit like a difficult part here in the section of solids. Or what you can do is you can just create a little difference between the light line and the thick line, and then afterwards when all the projection is completed, then you can actually erase this much portion so that it doesn't leave a flaw or doesn't leave a mark on the sheet. Because when you rub the pencil with a force against the paper, it generally leaves a mark on the paper. So this portion can then be erased and can then be redrawn with the light pencil or with the light pen. Now let's see in the next step what next has to be done in the question. So we have in the steps we have taken all the projections from the face edge or the base corners of the base 1 and base 2 towards the vertical plane. Now we will elevate, we'll take will form a cube here in the front view, because when we will be watching this cube in the front view, we can see the face edge A1, we can see the face edge D4, we can see the face edge C3, but this face edge B2, which is hidden from the spot of the front view, will be shown as with the help of a hidden line in the front view. Now let's see what comes up next in the drawing. If you really want to understand the method of projecting the drawings, it is a good way to watch the video tutorials. But if you would like to just go on having fun with the engineer, it is fun. It is definitely a fun when you learn it actually, and you can then solve plenty of questions based upon the same concept in the engineering drawing. So now we have marked the vertical section plane with HT, which is creating a horizontal trace on the horizontal plane. Now we have already had moved the projection lines till the reference line. Now earlier, if you notice in the previous step, that this line, this portion of the line was light line, as it was red in color, was a light line, because now the base of the cube, it is resting on the horizontal plane, it lies on the horizontal plane. So we had to remove the this much portion of the line which was light, and I had darkened this portion. So I've made this portion as the green pen, with the green pen. Now why have it is made of the green pen? Because the base 2 of the solid, which is resting on the horizontal plane, is then projected in the front view, and thus this projection, this much portion of the XY line is made dark, so that to actually show the projection of the cube resting on its base on the horizontal plane. And in the front view you will see the base of the cube. Now A1 visible edge from this point, this side, this is the front view, we can clearly see the edge A1. So this is the point 1, and this will be A. This is the corner of base 1, this is the corner of base 2. Base 2 corner is named as 1 because this is the projection line for base corner 2, and this is named as 1. This is the projection line for base corner A, base corner 1, A. So this is named as A. So when you watch from the top, you will see the first point A, and then you see the point 1. So it is named as accordingly. Now this will be named as accordingly as to this. So we'll name it as A, and we'll name it as 1. For the next part, we'll name this edge as, this is as D, and this is as 4. For the next part, when the B2 is hidden from us, we'll name this point B, and we'll name this point 2. And for the last edge, last portion of the solid, we'll name this edge, we'll name this corner as C, and we'll name this corner which is resting on HP as 3. Now let's see in the next step how we name these. Now you can see this in the question. I have marked the points as explained in the previous step. I've marked this as A dash 1 dash. This is the face edge 1, A1. It is called as A1 together. So this is face edge D4. It is also visible to us, so that's why I made this with the continuous thick line. A1 is also visible, is a continuous thick line. Then B dash 2 dash, B dash 2 dash. This is I've made with the continuous thin line, but the it's not a continuous thin line, it is a thin line, but it is a short dash medium line. And what is the application of a short dash medium line? It is used to show those edges which are hidden from us. So this edge, if I am viewing it from this side, this is hidden from this side of the front view. So I've taken this line as the short dash medium line. It is a light line, it is not continuous, it is a light line, but it is a short dash medium line. With the short dash, you all know about this convention, we studied this in the first class, not in YouTube, but actually physically I'm talking about in the class. So this is the line with the short dash medium line. And for the last, I've taken this projection till here, till the reference line. I've then taken a dark line because this is the visible edge C3 from the front view. Now this is the projection of the solid, right? So base of the solid which is on HP is a square, and the face edge of the solid is inclined to VP at 30 degree. The base is then resting on HP, so I've taken the base 2, which is 1 2 3 4 on HP, and hash is now shown by 1 dash 4 dash 2 dash and 3 dash on HP on the reference line. And then base 1 with center O1 is marked as A B C D and is shown in the front view as these points A dash, D dash, P dash and C dash. So we have also taken the cutting plane, which then passes through a point 15 mm away from the point of axis of the solid. Now if you can see that there is a hint in the question why I have taken a cutting plane here, why not here, because it was not a horizontal section plane. A horizontal section plane would have been placed like this, but it is saying it is passing through a distance of 15 mm from the point of axis. So the point of axis is actually point of axis, so the point of axis is visible from the top view. So I've taken a 15 mm distance from here and marked the vertical section plane, a section plane which is parallel to VP and then it is perpendicular to HP, makes an horizontal trace and thus comes as a line parallel to the reference line. Alright, I hope this step is clear to you. Now in the next step we'll be marking the cutting points. So how the cutting points come? When this line is passing through the face of the solid or the actual drawing, you can see this is the line we have drawn here, this is the line we have drawn here. We are actually assuming this is the line and this is the line. These are the face or the base edges of the solid, right? These are the base edges of the solid, not the face edges, base edges of the solid. How the base edges? 1 and 4 is the base edge of the base 2, A and D is the base edge of the base 1, C, D is the base edge of the base 1, and 3, 4 is the base edge of the base 2. For your understanding, C and D is the base 1, A and D is the base 1, 1 and 4 is the base 2, 3 and 4 is the base 2. I hope you're getting this point. And now when this line crosses across the base edges, when this line has crossed across the base edges, it creates this point. This is the point of intersection it creates. This is the point of the intersection it does create. So these points of intersection, this is the point of intersection, these are called as the cutting points. It means when the cutting plane cuts the solid, it cuts through these points. Now if I cut the solid like this, it will cut the solid from the base edge of the base 1 and from the edge of the base 2 also. So over here, this line, this whole line is having two base edges. One base edge is from the base 1 and the second base edge is from the base 2. As you can see, this corner is named as A1, this corner is named as D4. So this is base edge 1. Which is the base edge 1? Any guesses? So base edge of the base 1 is named as AD and base edge of the base 2 is named as 1,4. Over here, the base edge of the base 1 is named as DC, and the base edge of the base 2 is named as 4 and 3. Alright, so we have 4 cutting points, 2 on this side and 2 on this side. First point on the base edge of the base 1 and second point on the base edge of the base 2. First point on the base edge of the base 1 and second point on the base edge of the base 2. 1, 2, 3 and 4. Now we'll name these cutting points as you can name them as anything. You can name them as numeric, but you can actually encircle the numerics so as to avoid the confusion between these numeral numbers and these numeral numbers. Mark the cutting points 1, 2 on this side and 3, 4 on this side. So now 1 is encircled, so this point 1 cuts the base edge AD and the point 2 encircled cuts the base edge 1 4. So in the style it is written, 1 is written before 2, so it means that it will cut the base edge of the base 1, and 2 will cut the base edge of the base 2. If it is always written like this, it means 1, which is written before the second number, always appears to be towards the near towards your view, right? And 2 is then after 1. Okay, 2 is for the lower base and 1 is for the upper base. Likewise, 3 is for the base edge 3 C and D, and 4 is for the base edge 3 and 4. Now let's look how we will be projecting these cutting points in the front view so as to obtain a sectional front view. And the section will be made here. Why the section will be made here? Because if we remove this part, then this is the, from this point to this point, a section will be visible in the front view. After we have taken the cutting points on the cutting plane and the face edges it cut or the base edges it cut, we will always have to project these cutting points in the view, in the other view, so as to create a section which is visible in the front view. In yesterday's class, I made a cone which had this horizontal section plane, and it was creating a sectional top view. In this question it is different, it is creating a sectional front view. So from the top, in the yesterday's class, I dropped the cutting points towards the top view. Now in this class, if the cutting points are here, I would have to drop them towards the vertical plane so as to obtain the sectional front view which is being made here. So from the cutting points 1, 2, 3 and 4, for 1, 2, a single projection line is projected on the vertical plane, and then for 3 and 4, a single projection line is projected on the vertical plane. Now these lines are incomplete without these points coming here and without these points coming here. To inform you that there are no notations used with the cutting points, they are encircled here in the top view and they will be used as encircled points here in the front view. Please note that no dash will come in the front view, as these points are different in the front, different from the front and the top view points. Now through the projection lines 1, 2, 3, 4, when you moved it to the vertical plane, the 2 was between 1 and 4, so I have named 2 here between 1 and 4, as you can see in the front view, and 1 was between A and D, so I have named as this point 1 between the A and D. I will have to move this point, I have to take this point 2 till 1 and 4 only, and I have to take this point 1 till A and D. Alright, so similarly for cutting points 3 and 4, I have moved it through the projection line to the vertical plane. 3 will move to C and D, so I have not marked 3 here because this is not the position where the 3 lies. 3 lies between B and C, and B and C is available on the base edge. B and C is available on the base edge, on the base 1, and likewise 4 is available on the base edge 3 and 4 on the base 2, all right. So this is now we have got, this is what we have got here, and between these points 1, 3, 4 and 2, these are the cutting points and they are making a section. So between the cutting points, wherever the cutting points are lying, it is creating a section. So this is making a boundary. 4 is here, 3 is here, 1 is here, 2 is here. So it is making a boundary, right? When we are looking at these points, these are connecting each other and they are making a boundary, close boundary. So the close boundary which is created here is actually the section which is created in the front view. We will complete this question as the section is created. Now how will we be completing this question? As you can see, between the cutting point 1 and 2, this line is red in color. It means that this line is thin line, but in actual, if we see here, this is a visible edge. It is forming a visible edge. All right, so this visible edge will be visible in the front view. So this light line will be now converted to a dark line, and I'll actually remove the red pen here and I'll make it with the green dark line. I'll make it dark. Between 3 and 4 I'll do it dark. Between 1 and 2 I'll make it dark. And then between all the cutting points which is creating a section in the front view, I will complete it by using the hatching lines. Now what else is changed in the question? This face edge D and 4, when this portion was removed, this face edge was also removed along with the part of the solid which was removed. So this face edge which appears to be dark in the front view, whatever portion is removed, you have to make it light. So this dark edge which was light in the previous step, as it is light dark in this step also, we will finalize the question in the next step after we draw the hatching lines, and you will have to notice what line is dark in and what line is light. So let's proceed towards the next step. We'll be drawing the hatching lines and we'll be making this face edge which is now removed. As you can see in the top view, it is being removed by the cutting plane. We'll make this line light. There is a common question. There is always a doubt in the minds of the students that, sir, which line is light, which line is dark? Well, in the sectioning part, as you move on with the question in the steps, some light lines has to be made dark at the end of the question, and some light lines, some dark lines will be light at the end of the question. So I'll suggest you that you will have to start the question with the light lines, all light lines, and then you can remake the light lines to dark lines after the question is complete. You can also suggest yourself to make alternate drawing in the rough pad or rough paper, and by actually knowing what edges are visible, you can then do it later dark, and whatever edges which has been removed, you can then mark them as light edges. So this is the final drawing before the hatching step. So I'll make you understand. When the cutting point were here, 1 2 cutting points cut the solid from the base edge of the solid, it created a visible edge 1 2. So 1 2 is now visible edge over here, and between the cutting points 1 2 3 and 4, 3 4 is also the visible edge in the front view. Between the cutting points 1 2 3 and 4, you can actually see a section. So this is the section which is created with the base of the cube on HP and base 1 of the cube here, and this is the base 2 of the cube, this is the base 1 of the cube. Now the edge which was removed, D4 was earlier the visible edge, it has been removed after the cutting. It is now the removed edge which is shown with the, which has to be shown with the light line, and there were no visible lines here, so they were created after we had the cutting points, after the plane cut the solid, and now this is the boundary which is created. We'll complete this question, and next picture will show you the final question. So now I'm actually zooming in on the final section which is created. As you can see, all the green lines which are there are the dark lines, and all the red lines which are there are the light lines. So it keeps on changing, the line keeps on changing from light to dark and from dark to light. This is all what we have to remember in the section of the solids. You can assist yourself by keeping a rough pad along with your side and drawing the same drawing there, and then fairing up your work, then finalizing your work later on. This is how it looks. I think the more you will practice on the section of the solids, the more you will understand about the concepts. So this is how you do in the section of the solids. Alright, if you have any questions related to this type of question, please feel free to ask me through the comments in the comment box, and I'll video them later, and I will be answering them in the coming video lectures. So for the tomorrow class, I will be preparing another set of question for you, and if you have any if you want me to do any session on any other chapters, I'll be doing that also. All right, thank you for watching. Jai Hind.